Till now, let us continue our discussion. And till now, we have discussed about three models, which is first one was a hierarchical model where we observed a tree kind of structure. Then next one was network model where the graph structure was seen. And lastly, we discussed about relational model where we store data in form of tables. Now let us move ahead and understand about object-oriented model. Before understanding this model, let consider this particular example. Imagine you have a database, a relational database, and you have this table where you store data. So you are storing customer ID, you are storing first name, then you are storing middle name, and then you are storing last name. Okay. So it is good, and you can store data in form of in rows. You can keep entry of each and every customer. So now for a particular customer, it may so happen that the customer ID is 10, suppose. They may have some name, Priya. They may have some surname, Sharma. But it may so happen that they do not have their middle name. So what happens here is you're unnecessarily wasting the space taken by this particular block. So it is not optimal if you're thinking of data like storage optimization. This is not an optimal strategy. So what you can do here is for each and every entry, each and every customer, you can create an object where you can store all these things, and you need not to waste the extra space for the parameters which are not applicable. So I think this was clear, and you understood why the relational model fails and what are its drawbacks. So continuing the discussion, this is where object-oriented model comes into picture. It helps a lot with respect to flexibility. So let us begin with an example. Think of a video game character. Now, what a video game character will have? It will have a name, health, level, weapons, whatever it is. So instead of storing in form of tables like relational database, object-oriented databases stores everything in as objects with properties and behaviors. So what happens is you can store particular attribute which you want. You need not to waste space and waste for all the attributes in the particular table. You just need to fill the relevant ones. So it stores in form of objects, and it is very similar to object oriented programming. Oops. So each object attribute, each object has attribute and methods and some behaviors. So what happens? Each object has some attributes and it has some methods. Methods are basically, you can think it of as functions, like the object can has some capabilities to do. So uh, yeah, these are used in AI, multimedia storage, and gaming databases. So these are popularly used where we need a higher flexibility. Let us understand with an example. Continuing the same example of the game. Now, suppose if we define a player, it will have its attribute as name and its value as Alex. Then we can have its attribute of health having value of 100. Then we can have its weapons. Let's say it has a sword and shield. So what happens is you're storing these things. But note that previously we discussed about all these things and we didn't mention about level here because it was not relevant. So what happens is you store relevant information and you save space for the unnecessary ones. So I think it's clear about object oriented model. And yeah, so let us move and have a comparison of all the data models. So what we discussed till now, we discussed four models, and let us understand the difference between them and understand when to use which one. So to begin with, we'll discuss each property one by one for all four models. So to begin with, let's begin with structure. So hierarchical model has a tree kind of structure where one parent has multiple children, but one children can have only one parent. Now network model is a web-like structure. It supports many-to-many relationships, and we can have a like this multiple paths from one node to other. So multiple parents can one child can have multiple parents, and one parent can have multiple children. Relational databases, it stores in form of some tables, tabular data is stored. Object oriented, we just saw that. There we create object and we store the needed attributes. Now talking about flexibility, in hierarchical model, because we have one to many relationship, so it is not flexible. As we discussed, you can't go from one railway station to other railway station via only one path, but practically there are multiple paths. So flexibility is not there, or I can say it is very low in case of hierarchical model. But talking about network model, we can say it has a medium level of flexibility, because we have this supports many to many relationship and a lot of cases are covered in it, so it can have multiple medium kind of flexibility. Now talking about relational databases, these are widely used and it has a pretty high flexibility. Object oriented databases, object oriented models are much more flexible, and here, as we discussed, we can store whatever we want in whatever like relevant irrelevant fields you can skip, and that's why it provides very high flexibility. So let us understand why and where it is used widely. Hierarchical is used widely in file systems, organization charts. Then it is used in network model is used in banking, airlines. A relational model is used in business apps, websites. Then object oriented is used in gaming, AI, and multimedia. So as we discussed, these are the examples, and we have discussed when we discussed each model one by one. So let's move ahead. And the most important question of all the discussion which we had till now is which model is best. Like we discussed four models, and how do we decide that which model we have to use? So the answer to this question is depends on the use case, because no single model fits all applications. So we need to understand the use case first and then decide which model to use. So I think it's clear that we have a set of models, and depending upon our use case, we need to pick one. So let's move ahead and continuing our discussion further on DBMS. Let us understand about components of DBMS. So we have discussed few of them, like all of them almost. First one is data model. What data model does is it defines structure of data. The next one is database. It actually stores. This defines, this stores. Okay. So next one is DBMS. DBMS manages storage, like database management system. It manages storage, retrieval, and updates. Next one, last one is users. Users are the like people who actually interact with database. They can interact using applications, like they can ask for students with having CGPA above 8 or something like that. They can ask for data, they can write data. So these are the users. Users are the people who actually interact with database. Moving ahead, let us discuss about DBMS architecture, database architecture. Database architecture refers to how database system is structured and how users interact with it. So what happens is there are three types of architectures. Like we'll discuss one by one. So these are the three main types for one tier, two tier, and three tier. So what happens in one single tier is application and database are on same system. Suppose in my laptop I am having same app is there and database is there. So what happens is my app can easily contact with this database and interact with this database. So what happens is it is very fast to access and simple and easy setup, because it is only there in one system, need not to have any server, anything extra. Simple system where both the things are in one system. But what are the problems? Now imagine a situation where this particular system fails. So what will happen if your laptop stops working due to some other reason? You lose all the data, then you won't be able to work with it. So this system is not at all reliable. Like what if happens? There is no backup. So cons, if we talk about cons, it is like it is less secure. Then it is not scalable. Scalable means only I am able to use this because this is there in my system. In one system it is there, only I am able to use it. So the problem is if I want to launch an app or something like that, am I the only user who is going to use this? No, right? So people are going to use this, and this system cannot support multiple users. So let's see how other systems are. So two-tier architecture, what happens is application and client database server are separate. So what happens is there is some app, there is some database. These are two different systems. So what happens is your app gives some query and asks for something, and database gives response. So this is the communication that happens. It supports multiple users. Now since you have database as in a different server, you can have apps in all users, like all users can have apps and they can contact with this database. So it supports multiple user, and it is more secure than one tier because we are having things in different systems, right? So if one fails, we can have something backup or something like that. So, but it has some cons. It may cause slowdowns. What do I mean by slowdowns is if an application is talking with the database and with the help of these queries, so this process is slow as compared to the OS communication where both the things are in same system and we are communicating through OS operating system. So that is much more fast as compared to this system because we need to contact some other system, right? So it is not feasible. And then since we have multiple systems, we need to have maintenance of all these. So these are the two cons, like we need to think of it. So the third architecture is very popular, and it includes an additional application server between client databases and scale for better scalability and security. So what happens is this is client. Now client will have some application in between, and this will be contacting with server, database server. So what happens is it will have a systematic and proper communication. Client will give some query to application, then application will access this. So there is the proper layered structure. This is widely used by all the organizations almost, like Facebook, Amazon, banking systems, everywhere this is used because like we have Amazon app. So we're not going directly in Amazon's database and contacting like I want to do this, I want a list of items, new arrivals. This is not what we do already. So what happens is we go to Amazon's app, and then from there Amazon app asks the server. So this structure is widely used. Now, talking about like what to choose, when to choose which architecture. It again the same concept. Like, no of the architecture is fit for all use cases. So depending upon use cases, we are going to decide which architecture to use. So first tier architecture, one tier architecture is used for personal use and small apps. Like if your startup is there, if you're using for personal use, then it is very best to go with this because the other two have different systems and they come with an additional cost. So it is better to optimize and use one tier system. Then second tier architecture is used when you have small to medium applications like MySQL backend or web applications you can use so that they're not too large but affect a significant amount of people. Three-tier architectures are widely used and where large and scalable systems are there. Like as we discussed, Facebook, Amazon, everyone uses this kind of architecture. This is used in e-commerce, banking, and all. So thank you so much for this video, and we'll discuss about entity relational model in the next video. So till then, keep learning, keep practicing.